$12 million gone in one click.
And the worst part, the person who lost it probably thought they were being careful.
We're talking about one of the most insidious scams in crypto right now, address poisoning. It's not a smart contract exploit. It's not a protocol vulnerability. It's something far more unsettling.
It exploits the one thing we can't patch with code: human pattern recognition.
I'm Sarah.
I'm Ben.
And this is Infinite State, where we cut through the noise to understand what's really happening in crypto and blockchain infrastructure.
Today we're breaking down how someone just lost 4,556 Ethereum in what looks like a routine transaction. Because this isn't just a cautionary tale about copy-paste mistakes.
It's a window into how attackers are weaponizing the very design of blockchain addresses against us, and why this problem is only getting worse.
Let's start with what actually happened here.
So, according to blockchain forensics firm LookOnChain, a trader had been regularly moving large amounts of Ethereum to a Galaxy digital deposit wallet. We're talking established patterns here, right? This wasn't their first rodeo?
Right, and that pattern is exactly what made them vulnerable. The attacker studied this behavior, identified the legitimate Galaxy digital address the victim was using, and then generated what's called a poisoned address.
And when you say poisoned, you mean?
An address that looks nearly identical to the real one. Specifically, it matches the first 4 characters and the last 4 characters. So if you're glancing at your transaction history and you see 0x690 ... dd2e, your brain registers it as the address you've been using safely for weeks or months.
But it's not.
It's not. And here's where it gets clever. The attacker doesn't just create this address and wait. They start sending tiny amounts of Ethereum to the victim's wallet. Dust transactions. Pennies, essentially.
Why would they do that?
Because every transaction creates a record in your wallet history. So now when you open your wallet and look at recent activity, that poisoned address is sitting right there, mixed in with your legitimate transactions. It looks like part of your normal flow.
So it's social engineering meets blockchain mechanics.
Exactly. The attacker's basically seeding your transaction history with a decoy, and then they wait for you to make a mistake.
Which in this case was?
The victim needed to send ETH to Galaxy Digital again. Instead of manually typing the address or copying it from a verified source, they grabbed it from their recent transaction history, clicked the wrong one, sent $12.4 million to the attacker's wallet.
Just like that.
Just like that. Single transaction, irreversible. The funds hit the attacker's wallet immediately.
Okay, I need to pause here because I think a lot of people hearing this are probably thinking, well, that's just careless. You should always verify the full address.
And they're right. You should. But let's be honest about human behavior for a second.
Please.
Ethereum addresses are 42 hexadecimal characters long. They look like this: 0x followed by 40 random letters and numbers. When you're dealing with these multiple times a day, especially large transfers that you've done dozens of times before, your brain starts taking shortcuts.
You start pattern matching instead of character-by-character verification.
Right. You look at the first few characters, the last few characters, and your brain fills in the rest. It's the same reason we can read sentences where the middle letters are scrambled. Our brains are prediction machines, and attackers know this.
But what I don't understand is how the attacker can even generate an address that matches specific characters. Isn't address generation supposed to be random?
It is random, but it's also deterministic. This is called a vanity address generator. You basically run a brute force search, generating millions or billions of addresses until you find one that matches your target pattern.
That sounds computationally expensive.
It is, but here's the thing. Matching just the first and last 4 characters is actually achievable with consumer hardware. We're talking maybe a few hours of computation, possibly less if you have a decent GPU. And when the payout is $12 million, that's a pretty good return on investment.
So the barrier to entry for this attack is surprisingly low.
Disturbingly low, and it scales. You can target multiple people simultaneously, seed their wallets with dust transactions, and just wait. It's like setting 100 traps and seeing which one catches something.
What about wallets? Couldn't they build in protections against this?
Some are trying. You could imagine warnings that flag addresses you've never sent to before, or visual indicators that differentiate between addresses you've saved versus addresses from transaction history.
But that's not standard.
Not even close. And here's another layer. A lot of people use wallet interfaces that truncate addresses in the UI. You might only see the first 6 and last 4 characters by default. Click to expand for the full address, but most people don't.
So the interface itself is creating the vulnerability.
The interface is optimizing for readability and convenience, which inadvertently creates attack surface. It's a design trade-off that made sense when these wallets were built, but now we're seeing the consequences.
Let's talk about what makes this particularly nasty compared to other crypto scams. Because we've seen phishing, we've seen fake websites, we've seen social engineering. How is this different?
Most phishing attacks require the victim to take an action outside their normal workflow, clicking a suspicious link, entering their seed phrase on a fake site, approving a malicious contract. This attack works because you're doing exactly what you normally do. You're sending funds to what looks like your regular destination. There's no red flag, no "this seems sketchy" moment.
It hijacks trust.
Right, and it exploits transaction history, which most people think of as a trusted record. Your wallet is supposed to be your source of truth, but now that record has been poisoned.
I'm curious about the blockchain analysis angle here. We know this happened because firms like Look On-Chain can trace everything on-chain. Does that help recovery at all?
Not really. We can see where the funds went, we can track them as they move through mixers or across chains, but blockchain transparency doesn't equal reversibility. That $12 million is provably gone. We know exactly which address has it, and there's nothing anyone can do about it.
That's the finality of blockchain settlement.
Right. No chargebacks, no customer service to call. Once the transaction is confirmed, it's settled. That's a feature when you want unstoppable money, and it's a catastrophic bug when you make a mistake.
Are we seeing this type of attack increase?
Significantly. Address poisoning has become one of the fastest growing attack vectors in crypto over the past year, and the amounts are getting larger because attackers are getting better at targeting high-value wallets.
How do they even identify targets?
On-chain analysis. If you're regularly moving 6 or 7 figures in ETH, your address is visible, your patterns are visible, your destination wallets are visible. It's all public data, so attackers can literally build target lists of wealthy users and tailor attacks to their specific behavior.
That feels like a fundamental tension in blockchain design. The transparency that makes everything auditable also makes everyone a potential target.
That's exactly right, and it's not clear how you solve that without introducing privacy features that bring their own trade-offs.
Okay, so where does this leave us? Because I imagine people listening to this are probably terrified to send any crypto anywhere.
Healthy fear is probably appropriate, but let's talk about practical mitigations.
Please.
First, whitelist addresses. Most wallets let you save and label addresses. If you're regularly sending to the same places, save those addresses with clear labels. Don't rely on transaction history.
And always send a test transaction first.
For large amounts, yes. Send a small amount, verify it arrives at the correct destination, then send the bulk. It's annoying, it costs extra in gas fees, but it's a lot cheaper than losing $12 million.
What about address verification tools?
There are some. Hardware wallets often have better verification flows. They'll show you the full address on the device screen, which is harder to spoof. But even then, you're relying on yourself to actually read all 42 characters.
Which brings us back to human factors.
Always. And here's the thing. This attack works precisely because it understands human factors better than most security advice does. Telling people to just be more careful isn't the solution. We need systemic improvements.
Such as?
Better wallet UX that makes address verification easier. Maybe something like visual hashes, where each address gets a unique, recognizable image. ENS names, though those have their own risks. Multi-sig wallets that require approval from multiple parties. Hardware wallet integration that physically separates the signing process.
But none of those are foolproof.
Nothing is foolproof in security. You're always trading off convenience versus protection. The question is whether the current balance makes sense, and I'd argue it doesn't.
Now, I want to touch on something we haven't discussed yet, which is whether there are any blockchain architectures that could actually address this at a protocol level, rather than just the wallet interface.
That's a good question, and the honest answer is that address poisoning isn't really a protocol problem, it's a user interface and user behavior problem. Any blockchain that uses cryptographic addresses is going to have this vulnerability to some degree.
But there are different approaches to how addresses work, right?
Sure, some chains use different address formats. Some use account abstraction, where you can set up social recovery or spending limits. Some integrate identity systems. But at the end of the day, if you're sending funds to an address, you need to verify that address is correct.
What about something like the Internet computers approach? Because I know they have some different patterns around identity.
Internet Computer has Internet Identity, which is more about authentication than about addresses per se. You still have principals and account identifiers that could theoretically be spoofed in the same way.
So we're back to the wallet interface being the critical layer.
Right, though I will say, and this is relevant to broader blockchain design, the chains that prioritize better developer tools and better user experience frameworks tend to create ecosystems where wallet developers have better primitives to work with.
Give me an example.
Well, ICP's identity system allows for things like seamless wallet integration without manually handling keys for every interaction. And because canisters can hold assets directly and handle logic on-chain, you can build wallets with programmable guardrails, like requiring explicit confirmation for addresses you've never sent to before, or implementing spending limits that are enforced by the smart contract, not just a UI.
But those features have to be implemented by wallet developers. They're not automatically preventing address poisoning.
Correct. They're tools that make it easier to build better security, but they're not magic bullets. You could build similar features on Ethereum or other chains. It's just that the developer experience and the tooling might make it more or less likely that someone actually does it.
So it's more about the ecosystem's approach to security-focused UX than any one technical feature.
Exactly. And honestly, I think that's the broader lesson here. We spend a lot of time in crypto talking about consensus mechanisms and throughput and decentralization, but if the end user experience has massive footguns like address poisoning, we're not actually building usable money.
That's a good segue to the bigger picture. What does this incident tell us about where crypto is as an industry right now?
I think it highlights a maturity gap. We have incredibly sophisticated cryptographic systems, we have formal verification of smart contracts, we have all this cutting-edge technology, and yet someone can lose $12 million because they clicked the wrong entry in a list.
The technology has outpaced the UX.
By a long shot, and it's not even close. We're asking ordinary people to manage cryptographic keys, verify hexadecimal strings, understand gas fees, approve complex smart contracts. It's like if early email required you to manually configure SMTP servers and understand TCP/IP to send the message.
So how do we close that gap?
I think it requires a shift in how we think about building crypto products. Right now, a lot of development is focused on what the protocol can do, how fast, how cheap, how decentralized. Those things matter, but they're not sufficient.
We need to start thinking about what the user needs to understand and do.
Right, and we need to be honest about the fact that most people will never verify a 42-character address character by character. They just won't. So either we build systems that don't require that level of diligence, or we accept that these attacks will keep happening.
What would a system that doesn't require that look like?
Maybe it's account abstraction, where your address is actually a username, and there's a recovery mechanism if you make a mistake. Maybe it's multi-sig wallets that are the default, not the exception. Maybe it's social verification, where your wallet warns you if you're sending to an address that none of your contacts recognize.
Or maybe it's moving away from the mental model of addresses entirely.
That's the radical version, yeah. If you're building on-chain applications that feel like Web 2 apps, users might never see an address at all. They're just interacting with an application and the wallet handling is abstracted away.
But that brings its own trade-offs around custody and control.
Always trade-offs. That's the theme of this whole conversation. Security versus convenience, decentralization versus usability, self-custody versus safety.
And in the meantime, people are learning these lessons the hard way.
$12 million at a time.
So let's bring this home. If you're listening to this and you hold crypto, what should you actually do differently starting tomorrow?
Set up address whitelisting in your wallet today. Not next week, today. Any address you send to regularly, save it with a clear label. Don't trust your transaction history.
Test transactions for large amounts.
Always. If you're moving more than you're comfortable losing, send a tiny amount first. Wait for confirmation, verify it arrived, then send the rest.
Use hardware wallets for significant holdings.
Especially for cold storage. Hardware wallets with screen verification are much harder to spoof because you're verifying the address on a separate air-gapped device.
And maybe most importantly, slow down.
Yeah, I think that's the real takeaway. Crypto moves fast, DeFi moves fast, everything is optimized for speed. But when you're dealing with irreversible transactions and your life savings, slow is okay. Take the extra 30 seconds to verify. It's worth it.
What about at an industry level? What needs to change?
Wallet developers need to treat UX as a security feature, not an afterthought. Exchanges and institutions need to educate users about these attacks, and protocol developers need to think about how their design choices affect end-user security, even if that means sacrificing some technical purity.
Because we can build the most decentralized, trustless, censorship-resistant system in the world, but if people are too scared to use it, what's the point?
Exactly. Crypto is supposed to be an upgrade to the financial system, not a minefield that only experts can navigate safely.
And right now, it's still too much of a minefield.
Way too much. But I do think we're seeing progress. More wallets are adding safety features, more protocols are thinking about UX from the ground up. It's just not happening fast enough.
Especially when you consider that mainstream adoption means onboarding people who don't even know what a private key is.
Right. If your grandma can't safely use your crypto wallet, it's not ready for mainstream adoption. Full stop.
That's a high bar.
It should be. We're talking about people's money, their savings, their financial security. The bar should be high.
Okay, final question. Do you think we'll look back on address poisoning attacks as a specific phase in crypto's evolution? Like, is this something we'll eventually solve and move past?
I think so, yeah. In the same way that early internet security was terrible, people emailing passwords in plain text, no HTTPS, no two-factor authentication. We figured it out eventually, not because the technology magically improved, but because we built better standards and better tools and better education.
And because people got burned enough times that they demanded better.
That too. Pain is a powerful motivator for change, and $12 million vanishing in one transaction, that's a lot of pain.
It is, and I think that's where we'll leave it. This is a solvable problem, but it requires us to take UX security seriously at every layer: protocol, wallet, education.
And until that happens, verify your addresses every single time.
Thanks for listening to Infinite State. I'm Sarah.
And I'm Ben.
If this conversation changed how you think about crypto security, or if you have your own close calls with address poisoning, we'd love to hear from you. Links to everything we discussed are in the show notes.
And remember, in crypto, trust is math, but verification, that's still on you.